Hey, yeah, thanks a lot. So yeah, hello, as I said before. Yeah, it's great. This is my second LNUG. I was here the first time last month, and I really enjoyed the experience, and I really enjoyed chatting to people, and I got inspired and went on the speaker announcement thing and pitched in something. So yeah, I'm really glad to be here. A bit before I start talking, so a bit like a couple of points. So yeah, I know this is the node.js meetup, but this talk is more about browser JavaScript and kind of browser APIs. I think there's some crossover, like the JavaScript part, and also I think some of the ideas are kind of like possibly transferable. So yeah, and I've got a few links at the end which might be of interest. Another point is I kind of wrote a talk description on Meetup and the title, that really long title, but I kind of like, I had this idea in mind that I was trying to hack on, and then I didn't quite manage to get that hack together. So this has kind of changed what I'm talking about, but I think it will all make sense, and basically at the end you'll see how I failed, which will be fun. Cool, yeah, so I'm Ben. So I lead the onboard experience team at Wayve. So at Wayve, we're doing like autonomous, like self-driving cars, like end-to-end ML-based approach. And onboard experience is the in-vehicle kind of side of this, so kind of like how you interact with the AI systems and how you see what's kind of going on, and also kind of how you can kind of interpret some of the data that's coming out of it. I'm not going to be talking about anything vaguely related to what we do here, and I kind of want to make that clear because a lot of the stuff that I'm going to talk about is like very kind of like hacky, sketchy bits of code, and we don't use that to drive our cars. So just that. I am around later if you want to chat about this stuff and find out more. If you find out lots more, we're also hiring. You come in and have a job, and you'll learn loads. So yeah, we've got a couple of openings in our team. So give me a shout about that if you're interested in that. What I'm going to talk about is this idea of collaborative file access, particularly using browser APIs. And I'm basically going to take you through a bunch of like projects and hacks and stuff that I've worked on that kind of like has a vague thread through it. So what we're going to cover is we're going to talk about reading files with the web, writing files, origin private file systems, and then this idea of a peer-to-peer file server, and then peer-to-peer file servers, and like what those could mean. Cool, so let's start with reading files. So in a web page, you've got a couple ways to get a file into that web page, right? Like, so first is a file input field. So you can kind of like, this is just a form input. You can kind of select a file with it. The second way of doing this is like to use a drag and drop kind of set of events. So basically, if you cancel the drag entry and drag over events, then you can actually kind of receive that file and do stuff with it. A file, when you have that in your kind of like in your JavaScript, it's kind of like a node file in some ways. It's like it comes from it's based on a blob, so you have this. You have properties like you can pull out the array buffer, like the bytes of it, and you can also stream it. So in the exact same way as you can in Node as well. I built this project a while back called Hex. So this is basically a tool for viewing binary files, and like so I don't know if people have used like HexEdit or things where you kind of like want to see the bytes of a file. So I'm going to just like show you this quickly. So it's just a web page here. Yeah, so basically what I can do is I can click on this, and what that does is I'll make it bigger. It chooses that open file, like so it has a hidden file entry, so it kind of opens that. So I can open like a JavaScript file here, and then we're able to view this this content just here, right? So you can kind of scroll down. Something that I would say, another thing you can do is I can put in a bigger file, so it's a 2 megabyte one, and this is a drag and drop thing. So as I drag, enter, and drop, that file's transferred into that context. So I've taken a file from my file system into the browser, and I can kind of like interpret that. Something to notice is like, so this is quite a large file, and if I scroll down, I can't make it do it, it's still quite snappy, right? And this is like a technique that you use in browsers quite a lot, which is called a virtual list. So basically, how this is able to still be responsive is that it's only rendering elements from about here to about here, and then as you scroll, you're scrolling into those, and then it's taking them off. So that way you can kind of like, and And a file, like a hex file viewer, is a really great example of that because you know exactly which byte offsets you want to view and stuff like that. So yeah, just a kind of little side thing there. Another thing, so I built this with another way of interacting, which is to use a browser. So basically you can go in here and I can import a pop-up and then pass a file to it, and it launches that web page as a kind of new window and passes that data through a post message, which is another kind of random way that you can pass files between different browser tabs. So this is actually being kind of posted to this thing, and then you can kind of close it there. I think there could be some kind of interesting ways to like link that into a node process. So yeah, I think I've covered all those. Great. So yeah, there's actually, I should have shown that just now. I built this thing and I was like, this is super useful. You can view kind of like binary objects that you have in a browser. And then I think a few months later, Chrome shipped this thing that if you click on an array buffer, it shows you a memory inspector at the bottom, which is kind of, yeah. And it's a lot better than the one I made. So yeah, just that's a mini tip for you. Cool. The next thing I was going to talk about is, so we talked about taking files from your file system into a browser. I was going to talk about doing it the other way around, so writing files. So there's a file system API, which Chrome like proposed quite a few years back now. And what this allows you to do is it gives you a function called show open file picker, which basically gives you a reference to a file object, but critically that handle is also writable. And when you write to it, it writes to your local file system, right? And what you can do is you can get this handle and you can kind of, so here I'm appending some emojis and then closing the file, so you can kind of do that in a browser on a local file, which is kind of fun. So I've got another demo of this. So this is a thing that lets you kind of pull in files. So here, this is showing that file picker input. And then I can pick, say, well, let's pick whatever this is. So here's some JavaScript. And what I can do is if I kind of edit this thing, you can see that it says press that to save. And if I press save, it gives me that prompt to say, do you want to write that to the file system? And then I can save changes. And then that's actually changed in this main.js file. So you can see I've added those extra spaces here. So you can kind of edit files on your local file system back and forth. An interesting thing that I just noticed is like as you press save, you can see the CR swap file coming in, which I hadn't thought about this. But so basically, you can see this thing like as I kind of edit it, you can see a file appear really quickly there and disappear. And that's the way that Chrome kind of batches these file writes. And it's also a reason why it's inefficient. So basically, every time you write to a file, it has to create a temporary file and then overwrite it, which I might get to later. Cool. So the other nice thing about this is, so we were able to kind of like write to a local file, but it's also got a collaborative aspect. So if I click this share link, I get a link with some parameters on it. And when I link up that, it has the same file here. And what this now lets me do, I picked a really boring file, is kind of like edit it from the different browser, right? So, and this is like a kind of file cursor here, so I can say like hello, and I can say, I can delete that. And yeah, so this is kind of synchronizing those changes between those, but the cool thing here is like if I say hi, hell, I can actually still save that file here, because this has a reference to the local file system, whereas this one has the ability to edit it. This also works in multiple browsers, so I can have a third one here, and it can work with quite a lot more. So I can add that hello, LNUG, and then it's all kind of synchronized back to this first window, and then I can save it back to the disk and delete it from here. A cool thing about this is that these three are synchronized, but I can actually remove this one from the sync, and these two still collaborate, so they're still synchronizing together despite the origin kind of that file having disappeared. So we can kind of like synchronize, but the only thing is we can't now save to disk because we don't have that local file handle. How do I do that? Oh, and yeah, it might look familiar. This is the Monaco editor. So this is the same editor as comes out of, as is used in VS Code. So yeah, it feels quite familiar. Cool, so I've showed those things. Cool, so the way this works, so that synchronization is made possible by a type of object called a CRDT. So this is a conflict-free replicated data type. And this basically gives you this property of being able to change an object locally and then synchronize it with other peers. And it's resilient to things like partitioning and kind of like merge conflicts and things like that. What's cool is it works really well for kind of like document collaboration, like Google Docs style, what I just showed just then. But also you can have more kind of abstract documents. So this is particularly if you've got if you're using Node, you might have a document which represents some other kind of more less read-writey kind of objects, and you can kind of still synchronize that in that same way. And also some databases use this as well. React is one of these, so it kind of by design has this kind of eventual consistency synchronization property. Redis Enterprise also has a CRDT option. There's some kind of interesting stuff in that space. So for that thing, the reason I called it Y code is because it's using YJS. So this is basically a library that does this kind of handles these objects and allows you to kind of synchronize and plug them together. There's also some other ones. JSON Joy seems popular. Automerge is really cool. It kind of gives you some really good primitives for combining objects and sharing them. I've never used Laurel, but I found it this morning. And then there's also a blog post and a video which this has got a really good comparison about different using these different libraries for collaboration. And then there's a video which is a really deep dive if you're interested in that. Another thing is, so we have that YJS kind of document that is able to be shared between different peers. YJS also have these different providers, right? So if you've got a WebSocket provider, what that does is it has a central server that you connect to with WebSocket, and then you're able to kind of synchronize back and forth through multiple peers to that same kind of origin. IndexedDB is a local database in browsers. That is an experimental one which is a different kind of storage protocol, kind of cool. And then WebRTC is the one that I actually used. I'll explain in a bit. So this is using WebRTC to synchronize those objects rather than having a central server. WebRTC, I don't know, has anyone heard of WebRTC here? Cool, yeah, a bunch of us. So what that has is basically you've got these three browsers who want to talk to each other. They kind of talk through to a central signaling server, which allows them to kind of collaborate, to work out how they can communicate with each other. There's another couple of servers in here, a stun and a turn server. So the stun server allows you to kind of do this really cool NAT traversal via hole punching operation, which allows you to kind of connect two peers. And then a turn server works as a kind of proxy, as a kind of fallback thing. So basically, once you've got these, all the browsers can negotiate a peer-to-peer connection directly to each other. And this is super cool because it doesn't necessarily have to go through a network, like a public network. It could be just on your local LAN or something like that. LAN? Wi-Fi. Cool, so that's WebRTC. And yeah, these stun and turn servers help. I just wanted to give a quick shout out to Cloudflare because thanks for the pizza, and also they have got turn servers which are really cool. So yeah, I've been enjoying using those recently. And also, I felt unfair to say, not to mention Twilio, because I also Twilio also have stun and turn servers. And what I really like about them is I've had an account with them for 5 years, and I've spent 7 pence, which is kind of cool. Cool, right, okay, so back to File System API. So one of the problems with this is that it's not very well supported, right? So if I open up Safari, and I go here and I want to edit a file, it's not accessible, right? So Safari doesn't have the native file access. But what is nice is if I take another browser here, Chrome, and we're wanting to edit, say, this license. So I can drop that. Oh, that doesn't work. That's really awkward. Oh, yeah. So what I can do is I can take that file, which I can now edit here and save, and I can open that file reference in Safari, and sometimes this doesn't work. But yeah, so I can now edit this in Safari. So Safari doesn't have local file access, but this other browser does. So I'm able to kind of make edits in Safari, port those over to Chrome, and then write them to my file system, right? And I think there's something quite nice about here, where basically we're able to share capabilities of different contexts by communication, right? So the Chrome can write to file system, Safari can be Safari. And where this is kind of like interesting is like when you bring kind of like Node into the mix of this, like so like I think when you've got like multi-agents with different capabilities, having some kind of like worker or server-based process has a very different capability set than a browser. Like so I think there's something there which I quite like. Yeah, so as I said, the file system isn't supported by other browsers, and also there's not very much interest in it, or actually, that's the wrong word. There's enthusiasm, but also this is bad, right? Like, so this is, Mozilla has their specification positions, which is an amazing doc, and they basically give a really good position on this. They're really enthusiastic about it, but it's not, we're not able to kind of give meaningful end user consent to obtain that access to local file system. Totally legit. So that brings us to the origin private file system, right? Has anyone heard of that, by the way? Cool, excellent. Yeah, I hadn't either until recently. So what this is basically, it allows you to create a file system that is private to a particular browser and to an origin on that browser. So by an origin, it would be your URL, like so the domain, pretty much. And also the critical things is like this is separate from your user files, so basically is completely in a different process. And that thing that I showed earlier where Chrome creates a temporary file and then replaces it, it doesn't have to do that because it's not part of the kind of user space file system. And then other thing is like, so it's basically able to kind of be kind of maintained and cleared by the rest of the browser state as well. So when you clear all your cookies and your site data, it will delete the origin private file system as well. This is what this is like. So basically, you can create a root and then add some files, write some content, and then close it. And then, as I said, yeah, so this is the kind of in-browser process version, but there is a worker-based version which has a synchronous API which allows you to do this more efficiently and allows you to kind of do some more kind of extreme things. Yeah, so. I've got lots of demos. So this is basically a little thing I built to kind of play with the origin private file system. So what we have here is this basically displays that there's no files here. I've got some snippets here. What I'm going to do is I'm going to get the directory, create a hello text and write some text to it. When I run this, that has wrote the file very quickly. And when I refresh here, I can see this file has appeared in my origin private file system. What's cool is this is like consistent across different sessions. So and we've got this like 11-byte file here, and I can view this and see the actual kind of file contents. And this is being served from my private file system in the browser, which is kind of useful. What's nice about this as well is if I was to add some more files, like we got these ones here. That's 11K, so we can basically add different file types, and then I'm going to add some bigger files. And we can see it's taken a little while, but that's like 800 megabytes of files, just all within that private file system. And I can actually access, like, so this is a picture of my bike. This is a picture of my other bike. That was a total accident. But yeah, and you can see, like, so we can actually transfer, like, this is a 250 megabyte file, but we can actually just access it instantly, right? Like, so it's very kind of responsive. And that's what you can do with the origin private file system. You can kind of delete things from this. Yeah, the other thing, so basically if you look at this page, there we go. So you can see basically this is using a web component. So it's like basically a web component. That is basically a native element that has a kind of property behind it. The way this is implemented is I've got this web component element, and I've also got a worker. So you can say basically there's a worker here, and that does the kind of like scanning the files and like serving it there. So what this allows me to do, I think I added a comment here. The reason we need a worker here is that we need to kind of create this sync access handle. So basically that lets us kind of write files to this back and forth in this file system really efficiently. And we can do stuff with that. Cool. Nice one. Oh, that was a link. Cool. Yeah, so like as I said before, there's something cool about like basically, if you can do performant operations on files, you can do that in node land, but you can also do it in a browser as well. And there's something cool about like sharing those like units of computation between those. Another cool thing about browsers is that you can rapidly generate a lot of data. So basically, if you're recording from a camera, or if you're connected to a device that is outputting a lot of data, you can save that really rapidly to that browser without having to kind of synchronize it with any offline process. I put in stack blips here. There's like that's a kind of cool thing. It's like a web-based IDE for editing files, and it's got some really cool properties, and it uses that. And then you can implement databases because you've got this like lower level access. Cool, right, okay, then the other thing I was going to show is like, so that's like basically OPFS, and we're able to serve files from a local file system. I was wanting to kind of mix these last two things and think about how we could have a peer-to-peer file server. So my idea with this is basically you could have a local browser set of files, and then you could use WebRTC to connect to that browser and download them between them, right? So I was like I started implementing this from scratch, but then I remembered that I'd done this hack a while ago where I'd basically built this thing which implements gRPC over WebSocket connection, and basically allows you to kind of do a peer-to-peer gRPC, like if those, yeah, there's something kind of weird about it. But I figured I could implement it in there. So what I did was I implemented this OPFS service which allows you to list files and fetch them. And I'm going to show you that. So basically, how this PRPC thing works is you do host, and I'm going to say LNUG. And this has created a peer server. So this is acting like a server. This is acting like a client. And you can see basically I can mount different services on here and connect to these. These are just like using direct peer-to-peer. Cool, someone else joined. That is awesome. Right, okay. So basically, I've got this file server version here. I've added some files here. And so those are actually in this browser here, but I'm able to kind of like download them in this other browser and see like Ryan's shed or Chris's car, all this kind of stuff. So basically, I'm able to kind of like store it in one browser, access it in another. I don't know who this other peer client is, but they might be able to access it as well. So yeah, that's what I was kind of hacking into. Cool. So yeah, some cool stuff about that is like there's something there which feels kind of like an edge node of a kind of data center or something like. Yes, nice. That's so good. Found the shed. Something like an edge node of like a Cloudflare worker or something like that. And then also, I think there's this cool property of basically transforming on the device itself. So something that I hadn't implemented there is like, I like the idea of like trying to access a 5 gigabyte file, but then trimming down to pull out the first kind of like resize it to a different video or something like that, all those kind of things. So those are some things I'd be interested in. Cool, that's all the stuff that I've built, and then this is the things that the thing that I actually want to build, that I started building and made some progress on. But basically, we've had that like OPFS server, and then you've got these different clients connected to it. I really like this idea of having like lots of different services that have their own sets of files that they've generated themselves. They're able to like collaborate on that. And the thing that I was gonna be building with like the idea that I was wanting to explore is the idea of like maybe recording from lots of devices simultaneously, and then having like post-recording access to those files. So basically, I think there's some kind of cool stuff in there. And like I've added a little node process in here. I think it'll be like there'll be some kind of coordination thing, and like yeah, that's what I'm gonna build. Some other random stuff that I didn't manage to kind of like fit into this talk was like so. In Nodeland, there's a really cool project called Hypercore and Hyperswarm. So this basically gives you what I'm describing, which is like this kind of a swarm. It's such a stupid name. A swarm of different Hypercore nodes, which are append-only logs, which are able to kind of be accessed. So basically, you can append to your own local log and then access it from other clients, nodes, which is really cool. IPFS is interplanetary file system. Some really cool stuff there. You can basically register an object with a content addressable ID, and then you can access it from anywhere in a network in a kind of peer-to-peer way. Very nice. I would have used this, apart from it seems quite hard to append files. I don't know. some stuff that I'm wanting to look into is this idea of like multi-camera, multi-audio, and then like kind of maybe like in that kind of scenario, maybe a file isn't the right abstraction on that, and I'm kind of like looking into whether or not a stream might work or something like that. Anyway, that's that. So yeah, thank you very much. I'm on the Bird thing at Benjamin Ben and on GitHub, and I've got a website. So yeah, thanks a lot. Oh, questions? Yeah.
There will be questions. Will you take questions?
Yeah, sure, totally.
Starting in front there.
What do you mean it's hard to append files on IPFS?
I thought that because it's content addressable, the idea of it is the content of the file, and then so basically you're locked in once you've written it, I think. Whereas I want to give you a reference that I can then add more stuff to.
No, you can't. That's the whole idea. Once you put something, it's like it's a block.
Immutable, yeah.
So this idea,
Yeah.
when you put it there, it's going to be there forever.
Yeah, so I'm not so interested in that side of it. Like, as in, like, I'm more interested in like the kind of like the kind of mutableness of stuff. So that's why it wasn't suitable for what I was playing with.
That's the idea.
Yeah.
So basically, here the fast file system allows to create clientless torrent. So you can share, for example, video streaming. The more people you have, the more.
Yeah, totally. So there's a really interesting project which, what was it called? I think it was like some web CDN or something like that. It was like, I forget the name of it, but it was like, it was doing a similar kind of thing, like basically this observation that if lots of people are downloading a web page or an asset, then they should be possibly peering that at the same time or something like peer CDN or something like that. And yeah, it was like a really cool idea. I think they got bought by Google or no, by Yahoo. But yeah, is that where you're suggesting?
Yeah, but you need TON and STUN servers to bypass incoming connection.
Yeah, once you've used stun to establish that connection, then you can use it for like multiple files, I guess. So if you know that two people are on the same origin, you could have a web worker in the background that connects the sessions potentially, or something like that. I don't know. Ooh, cool, yeah.
Any more?